Sarita is well known and well regarded in the computer architecture community. She's been recognized time and again with various awards for her impact on the field. But for those who aren't familiar, let me highlight a few research areas she's contributed to. Her early work on data race-free memory models forms the foundation for consistency models used in most hardware and software systems today. And since then, she's made contributions, including innovations in heterogeneous computing, software-driven approaches for hardware resiliency, and most recently, the Illinois Extended Reality Testbed, or ELIXIR, which aims to democratize extended reality systems research. And there was actually an Ask Boss tutorial on ELIXIR yesterday. The video of that I think will be posted online if anyone interested in missed that. In addition to all these technical accomplishments, Sarita's professional integrity, commitment to service, and efforts to make our community stronger, more inclusive, and more representative are, I believe, equally worthy of admiration and emulation. She's served on countless program committees, governing bodies, and advisory groups. And among other initiatives, as YArch chair, she co-founded CARES, which aims to address discrimination and harassment in computer science research events, and which won the CRA Distinguished Service Award. She's also a recipient of the University of Illinois Campus Award for Excellence in Graduate Student Mentoring, which I can personally attest was well deserved. I feel incredibly privileged to have had her as an advisor while in graduate school and continue to have her as a mentor today. Joel Emmer mentioned in the earlier keynote that students begin to resemble their research group or advisor in style. And I hope that's true because I really like Sarita's style. So today I'm grateful that she'll be sharing some of her accumulated knowledge and wisdom with all the YArch attendees. So Sarita, thanks so much again. I'll hand it off to you.
Oh, thank you, John. That was extremely flattering. Thanks. Okay, so let me start with my title, Habits for Happy Success, Reflections from my Anti-Bio. And I want to start with a quote from, it's paraphrased, from you. This audience probably, you don't know Sidney Burris. He was a professor at Rice University, later became dean, and was one of the senior people there when I joined Rice. Sadly, he passed away just last week, and this is a quote that I've often thought of, and it's particularly relevant today. When I was a struggling junior professor, Sidney almost sat me down. He was famous for giving all sorts of amazing advice, and he told me, look, Sarita, you are going to be successful. The only question is, what shape will your success take? And I think this is a really important question that we should ask ourselves. All of you here, the fact that you are here, you've made it so far, means you are going to be successful one way or another. And really, the only question to ask yourself is what kind of success is it going to be? And I will share with you some things that I've learned, some habits that I've picked up that sort of define my style and what I view success to mean. Okay, so let me start with a little bit of history, a conventional bio that you will see in my resume. I grew up in India. I got my bachelor's degree in 1987 from the Indian Institute of Technology, Bombay. I spent 1 year at Johns Hopkins starting my PhD program, and then transferred to Wisconsin, where I got my PhD in 93. And then I moved to Rice as an assistant professor, stayed there for about 6 years until I got tenure. I was just getting tenure when I moved to University of Illinois as an associate professor, then became full professor there, and I have been at Illinois since then. And over the years, wrote lots of papers, had great students like John, and won some awards, got lots of funding, et cetera, et cetera. It's a pretty conventional kind of resume, right? So one thing I should add is that a lot of this resume and a lot of what I'm going to tell you, and for many of us, our professional lives are really intricately tied to our personal lives as well. And so I will put some details of my personal life. Um, so in IIT Bombay, I met my future husband, Vikram Adve, who some of you know. And then we had a long distance relationship at, while I was at Hopkins, he was at Wisconsin. So then I tried really hard to move to Wisconsin. We got married. And then when we both graduated at the same time, it was a really bad economy. Getting two positions, faculty positions in one place was pretty much impossible at that time. And so I took a faculty position at Rice, and Vikram took a research scientist position at Rice. He actually changed his area completely at Rice, and he reinvented himself as a compiler person. But we both wanted to be faculty somewhere, and so we had this two-body problem, which luckily we were able to find positions in one place, but we wanted tenure track positions in the same place, and so that's what precipitated our move. So I started at Rice at Illinois in '99, and we were expecting our first kid when we moved, and Vikram started as an assistant professor, and I started as a tenured associate professor. Okay. And then we had our first kid, and then in 2005, Vikram got tenure, and we had our second kid about the same time. Right, so this is all happy stuff, right? Sounds like we had a really very easy, smooth sailing life. But then here's what I call my anti-bio, right? So things that you will never see in my bio, and things that happen to real people, right? That happen to everybody, will happen to you. And I want to use this to get some lessons across. Okay, so first thing for my PhD, well, when I applied to Wisconsin, I really wanted to get into Wisconsin because Vikram was there. I was denied admission. Okay, and then so first I was denied admission, and then I was lucky that the work that I started doing at Wisconsin, so I did get admission, of course, finally. My first paper got in, but actually I had a really hard time convincing people in industry about our approach, and you will see that through this talk. And in fact, and at that time we were still at a stage where journal papers were important, and my key journal paper was actually rejected several times, and it was like when it was finally accepted, the editor made us remove what I thought was the critical insight in the paper, and it was really annoying. And I went to my advisor's office and cried. I mean, literally cried during this time. Okay, then when I went to Rice, my brother was diagnosed with cancer just a year into my tenure as an assistant professor, and by the time I came up for my third year review or fourth year review, so at the end of 3 years, I had published exactly one paper from my group. I did have another paper, but that was led by a senior colleague. And it was nice to have to have worked on that paper, but it wasn't like something that I drove. And I had a tutorial on my thesis work, which is one of my most widely cited papers, but it was from my thesis work. So my mid-year review was not great, and I think that was about the time when Sydney gave me that quote. So struggling a little bit here. Then when I became associate professor, when we moved to Illinois, we had our kid. Vikram was an assistant professor, trying to get tenure and everything that goes along with that. And I had a newborn, new job, new place, not many friends. It was just really hard. I mean, really, really hard. And I came very close to giving up. And it was hard. Like, what can I say? And then during this is before I got promoted, I got involved with the Java memory model. I'll talk about that. And even there, it took us 5 years to get. In 5 years, we got just one paper. It was a really, really hard, difficult effort. And that's the only paper that I got out of that effort, along with a lot of awards. But that was later, right? That was much later. And even here, I just almost came close to giving up. It was a matter of we tried, we had an approach, and we were trying to convince the entire PL developer and researcher community to adopt our approach, and it just, there were times when it just didn't feel like it was going to happen. And I had no funding, no students. I was the only one I was working on this with others, with other senior people outside, and it was just difficult. At the same time, I was also working on the GRACE project, which at that time I think was well ahead of its time. It was I think it was the first cross-layer adaptation for energy quality performance type of project, where we were working with architecture, OS, network, and applications people, trying to adapt all of these layers of the system together to jointly optimize all of these quality metrics. And these are all buzzwords now, right? Cross-layer, co-design, joint optimization, optimize for quality of service, et cetera, et cetera. At that time, this was all new. And it was a great project. I learned a lot. I still use this work in the project we're doing right now, but we couldn't get a paper published on this specific project in architecture conferences. So we did get them published elsewhere, but not in architecture conference. So it was really frustrating. Yeah, okay. And then after 2005, when it was time for me to be promoted. I'd just gone through this phase, right, that I just talked about. And the first time that the promotion and tenure committee met, they declined to promote me. I say, okay, she's not ready. I was really mad. So, and really upset. But okay, so that was that. The next project I did was the de novo cache coherence related work, which later on, got lots of awards, etc., recognition, and we still continue along, inspired a lot of later work, but many rejections, couldn't get it into a first year architecture conference. Finally ended up publishing, not in the top 4 architecture conferences. It got a best paper award in that conference, but had to deal with many rejections, and then the story continues, right? So I have more that's more recent, but again, the point being that it's not, this is not my life, right? This is my life, okay? And I want to tell you how and what it took, right? What I got from this, and why we still keep ticking. So the first habit, right? The first habit that I learned was don't give up, right? Just don't give up. Believe in yourself, okay? And then the question is, well, but how do you do that, right? It's not like you wake up one fine day and say, okay, from today onwards, I'm not going to give up, right? Or you don't sort of, you're not just born with this don't give up kind of gene in your body. Okay, it is a habit. It's totally a habit. It's something you teach yourself. So how do you teach yourself this, right? How do you learn to believe in yourself? And I have some thoughts on that I'm going to talk about, but first I want to go through this anti-bio again and reinforce that indeed not giving up made a difference, right? So I was denied admission at Wisconsin, but then I went to I actually went to Wisconsin, to the department, and talked to the professors there and somehow convinced them to admit me. Okay. This business of the journal paper, yeah, it got rejected, and yeah, I cried before my advisor, but we kept resubmitting, fixing it the way the editor asked us to fix it, and it got accepted. Well, brother fortunately was recovered, but part of that whole exercise was how our family just came together, and that tightness, closeness of our family has been really important for me throughout my career. The reason that my mid tenure evaluation wasn't that great was we were actually working on something that was difficult, and I'm going to talk about that in a bit. And it took a while. It took a while to mature, but just right around that time, right around 3 years, it just took off, and we had a lot of papers. things blossomed. And by the time I came up for tenure, there was no question I was going to get tenure, right? So some of the most famous computer architects wrote letters for me, and I was very happy. And there was just no question, right? So things really worked out. And then same thing with, of course, I didn't give up with my newborn, and I mean, existence proof that it is possible to have a successful career with a husband who also has a successful career, have 2 kids, and have a happy family, and all of that, right? So it works. Okay, it can be done. The Java memory model happened, right? All of the ups and downs notwithstanding. And as I alluded to before, it was the starting point. Really, this was the starting point for a lot of the awards and recognition that I got, and became really important for my own to inspire more work from me, take more risks, etc. And the GRACE project, yeah, we couldn't get a paper published in architecture conferences, but we did get publications in multimedia conferences, got lots of recognition there. And more important, that work, it still remains one of the pieces of work that I personally am proudest of. And I use this even now, because the principles that we learned there are very widely applicable, and they're foundational and still important today. And then again for professor, yeah, they put me up finally, and then I did get promoted. I became, I got an endowed position, et cetera, et cetera. And the de novo cache coherence, it's a defining project in my life, and really helped me understand the foundations of cache coherence, what it really means, and has affected a huge amount of work, including work that John did and that received several awards later on. Okay, so you shouldn't give up, right? But how do you learn to not give up? Okay, how do you learn this habit? So I have there's one sort of thing that I distilled out thinking about life. All right, I think the way I developed this habit is by teaching myself to be comfortable being uncomfortable. Right? You've probably heard this phrase several times. This is not my phrase. And just always trying to work just a little bit outside your comfort zone. So what that does is, you're sure to fail in many ways. Okay, you're sure if you adopt this habit, you're sure to not, everything's not going to be hunky-dory all the time. And so what happens is, slowly, so you build up this tenacity and this resilience, and learn to deal with failure, and then that promotes you to reinforces trying to work outside your comfort zone even more and more and more. And the side effect of all of this is that the kind of work you do is often sort of, it's not just jumping on the next bandwagon. It's like just a little bit outside, right? Just a little bit outside of the condition, and the impact that you make often tends to be much higher than what you would make if you were working, inside your own little shell. And so this is something that I always think about, and it's come to a point where if I'm too comfortable, I'm uncomfortable, meaning that I think, okay, this is just too easy, right? So okay, so working outside comfort zone. So let me give you some examples. And I also want to emphasize that that this happens slowly, right? So if you're interested, if you've been working on classical computing and so on, I'm not saying overnight you start working on quantum computing, right? That's not what I'm talking about here. This type of thing happens slowly and for a reason. So let me give you some examples from my own career where this stretching out little by little has served me in good stead. So when I was doing my PhD, the work I did was on data race-free memory consistency models. And this was a hardware problem. I was trying to be a computer architect, but the reason that I was able to make any impact at all is that I stretched a little bit and took a software-centric approach to this perceived hardware problem. And really, I had no training in this type of approach, but it seemed like the right thing to do, and we did it. And in fact, a third of my PhD thesis was proofs. We had no simulations, no experiments, no numbers in that thesis. Well, I had theorem numbers, but other than that, no experimental data. And so this was kind of different, but seemed to work. And then when I got when I was working towards tenure, this proofs business wasn't going to cut it. I realized that if I wanted to become an architect and get papers in ISCA and so on, I had to get out of my shell here. I got too comfortable trying to think about things mathematically and abstractions and all that stuff, and I needed to do something more concrete. And plus, as you will see, this was sort of the demand for the problem that I was working on. And so my first two students, Vijay Pai and Partha Ranganathan, I got lucky in finding in having those two in my group. So we started to build this simulator, the RSIM simulator, which was the first simulator to model out-of-order processors in a shared memory multiprocessor. Now, we all used to simulation today, right? We have complicated simulators, but you have to remember, simple scaler hadn't arrived yet. It was actually in development at that time. I did not know that. So not only had I never written a simulator before, I had never worked on out of order, instruction level parallelism, etc. And we were trying to build the simulator in a multiprocessor. And the Stanford people had just written their, I think it was called Tango. I think it was the first real sort of trace-driven simulator that shared memory simulator that was present in academia, and we sought to just combine these two. And I think in hindsight, it was, had I known better, I would never have done this. And that's a recurring theme, is that I look back and I say, whoa, what the hell was I thinking when I started this project? But that's that's about being comfortable being uncomfortable, right? So so we built this simulator, and the point was not to build a simulator, right? The point was to do something with the simulator. But the simulator took many years to actually build, which is why we had that 3-year gap where not much happened. But having this tool, and it was a one-of-a-kind tool at that time, helped us do quantitative evaluations of memory models that then went on to define, my thinking and understanding and so on. And so this was the first quantifications of using speculation for strong memory models. We were, I think, among the first people to actually identify the role of memory level parallelism in the context of larger, memory intensive systems and so on. So we had a bunch of papers that were, lots of ISCA papers and so on, and very well regarded, and no problem getting tenure. But again, working outside of the comfort zone. Then when I became towards full professor, this was the time that I had my baby and so on. Started working with Grace, the project with the cross-layer optimization, etc. And this was work with signal processing, networks, OS, and multimedia faculty. So this was a true interdisciplinary kind of work, completely, not my, I led this project, and it was, quite outside my comfort zone. But again, precipitated by a real need, seeing how power was becoming important, and how working in just, this one sort of layer of the system, just thinking about architecture and, thinking about just DVFS, etc., from an architect's point of view, wasn't going to ever cut it. We needed the rest of the stack to participate and be able to control all of the flexibility that architects were providing. And so, this was an amazing learning experience for me. The Java memory model was, again, totally outside my comfort zone, in the sense that I was not trained to be a languages. Somehow I got through Wisconsin without taking a PL class at all. And I was working with a whole another community. And even though I was pretty passionate about my ideas for the memory model itself, the place where we were applying them was very new to me. And then post promotion, after full professor, there are no more promotions in academia. The de novo coherence protocol, it came about because of conversations with programming languages people in the context of a language that had a type system that seemed very valuable and an interesting take on the problem, and helped us think about coherence in a fundamental way. I think this goes back to a point that Joel was making in his keynote this morning about thinking about constraints. And here we said, suppose everybody programmed in such type safe languages. What does that do to coherence and consistency and so on? And even though we started out with that constraint, later on our work threw away those constraints, but was very much defined by a thinking in that constrained world. But again, different way of thinking about things. I didn't even know what type systems were, and so on. And then worked, and this work still continues. We're working with software engineering faculty here on how do you do software engineering for hardware errors. And then our latest project on extended reality. Again, started this without knowing anything about extended reality, and I will tell you the story if depending on how much time we have. But now we have the first fully open source AR, VR, mixed reality, extended reality system that it's an amazing, we call it a rich playground for architecture and systems research, because it provides us with a complete end-to-end system where we can truly do research on domain-specific systems with cross-layer and cross-component optimizations, and working with OS people and compiler people, trying to actually build systems with multiple accelerators that are communicating with each other towards end-to-end quality of experience metrics. And we don't know of other. Let me just say it's a unique test bed, and not to mention the XR space is amazing, but completely, again, I knew nothing literally of XR 3 years ago when we started this. So again, the theme of working outside your comfort zone, and the reason it's important is that usually working outside comfort zone means it entails you're bringing in a new perspective to an area, bringing in people. Bringing together people from different areas and thinking of problems differently, and that often leads to impact of the sort that you wouldn't have if you stayed in your own sort of comfortable way of thinking. So and then the reason I brought this up was in the context of not giving up. So every single one of these, as I've told you, reached a point where it was like, okay, this just is too hard, right? It's too hard, but then you keep going because and you keep going. Oh, and then the cigar chair, right? Changing a lot of cultural issues, which was another whole story of getting outside comfort zone. So yeah, so the question to ask here now is, well, doesn't this get too hard, right? I mean, over and over again, you're doing these things, you're failing, you're saying don't give up. How do you sustain this? So here's the next habit, the next secret. Okay, and that secret for me, at least, is to be passionate about what you're doing. Okay, believe in what you do and just go all in. I don't know how to do anything without going all in. It's just a habit. But what that does then is that when you do fail, right? When you reach those difficult moments in time, it's very easy then to think back and realize, why are you doing this, right? And then you remind yourself, I'm doing this because I believe in this, and if I believe in this, I'm going to keep going. Okay, so it just, for me, it's happened to work out. So what does it mean to be passionate? I gave this talk, this type of talk once, and I said you should be passionate, and someone asked me, but how do you become passionate, right? What does it really mean? Okay, so I will tell you a story of a research project that maybe will convey how you become passionate. Again, you don't just sort of wake up one morning and say, oh, I'm going to be passionate about memory models for the next 10 years of my life, right? That's not how this happens. Okay, so some of the steps that I have found in kind of having passion is, first, the problem that you're trying to address. I mean, make sure you understand what the problem is. You'll be surprised how often people work on a problem without truly understanding the problem itself. And this requires a lot of reading, understanding. You talk to people, find out what they're thinking. Why, who cares, right, about this problem? How what you're going to do is really going to, change, address what people care about. The second thing is question fundamentals, right? So yeah, you're trying to solve a problem, but don't get stuck in that box that has been defined by someone else for you, right? Always ask, why is this problem the way it is? If I'm looking at a solution, why do you think it's not going to work? Why do we make these assumptions? Just don't be afraid to demand change. Okay, if you think people should take a software centric view of a hardware problem, don't be afraid, right? A lot of people will tell you, oh, the world is not going to change overnight, blah blah blah. But at least for me, I don't like to think that way and take risks. Okay, so just it's fine to take risks. And then finally, and these are all related, these 3 points are all related. Finally, focus on impact, right? If you're focusing on, oh, I want to get the next paper, I mean, it's fine, but that's just not how you're going to typically, right? Again, everybody's different, but at least for me, what does work is just always having a vision. That vision is always many years away. The next paper is not going to deliver on that vision. Okay, so it's always many years away. Always trying to think about how am I going to make an impact, and impact means changing minds. It doesn't mean writing 20 papers on a subject, right? As I said, for the Java memory model, it was just one paper for me, but it was a huge deal. And Elixir, for example, it's taken us 3 years to get just this test bed, but it's okay. That's fine. Okay, so it takes time. So let me see if I can get through an example. I have a lot of details on the next few slides because each slide really has a story, and I'm not going to be able to tell you all those stories, but I have some details in case you have questions later. Okay, so I'm going to run through my story of the memory models work just to make all of this more concrete. Okay, so I think many people who've heard me talk about memory models would come away thinking, oh, she's really passionate about memory models. But I started this work in 1988, and I was not passionate about memory models in 1988 for sure. Okay, I barely even knew what was a memory model. My advisor Mark Hill said, okay, here are some papers, read them, and go. So the point is, the starting point was to understand what is a memory consistency model. So remember that first bullet in the last slide. You try to understand. And at that time, the only sort of consensus that people had about memory models was that the simplest model was sequential consistency. But then there was this whole other plethora of memory models, and the prevalent view then was that of a very implementation, performance-centric type of view of the memory models. And this was related to the order in which memory operations execute. So all memory models were defined in this way. That in some memory models, a store followed by a load the order is not going to be respected, and so you put a fence there if you want it to be respected, etc. And there were many complexities, many ambiguities. And there was a new memory model. I like to joke, there was a new memory model virtually every day, and I would invent a new memory model virtually every day, going to my advisor with some idea or the other. But really, what was always annoying was, really, what is a memory model, right? Fundamentally, what is this thing? And really, fundamentally, it's very simple. A memory model means it's the definition that tells you what value a read can return. It's not about how you order things or blah blah blah. It's simply the specification that says, oh, here's a load. What value is it allowed to return? And this was, in some sense, an epiphany. And I've used this slide for 30 years now, right? And it's still important to understand that the memory model is a thing that tells you whether these reads of X and Y, they can return 90 and 26, or whether they can return, or whether they're required to return 90 and 26, or whether they can return 0. And once this was understood, right, then it became clear that this is not a hardware thing. This is a hardware software interface property. This affects performance, programmability, portability. And so we can't be sitting and defining it in terms of this order and that order. And so, we took a more software centric view of this and came up with a data race free approach, which is essentially a contract between hardware and software. And so we said, okay, so sequential consistency of that if programs are data race free, if the programmer obeys the data race free contract, then the system will give sequential consistency. And there's reasons why this also gives high performance, high programmability, portability, et cetera, et cetera, et cetera. And I honestly, I still remember the moment that Mark and I were sitting and that aha moment of this sort of insight. And it's a very simple insight, right? Oh, and then I want to acknowledge a lot of people along the way with, lots of work together, building on these ideas. So this is a very simple insight. It can be described, very simply, but the work that went in, um, the data race fee is one contract, but I've worked on many different hardware software contracts with different hardware optimizations, dug as deep as possible. And most of this work really is unpublished. Okay. But this work was necessary for that passion. This is what made me believe that we had the right idea. This was the right approach. This is how you do things. It's not about the papers. It's about understanding. And understanding is something that I really, really love about my job, is that it gives me the freedom to spend as much time as I want to actually understand a problem and solutions to it. And I really enjoy that. So that's where the passion comes from for me, right? For me. And then and then because I was passionate about this, we continued on. I have to say that even though I was passionate about this, not many people shared this passion. So it was really hard. I go to industry and they say, "Oh, we're going to do release consistency. You reorder this and reorder that and blah blah blah." I'm like, no, that's not the way to think about this. Think about it in terms of sequential consistency for data race free, but it didn't seem to stick. Okay, so next phase at Rice as a assistant professor, I said, well, okay, so we have to show performance benefits, right? Unless I show performance benefits as an architect, there's no credibility for anything I do. So we built the simulator with Vijay and Partha, and the numbers gave us more confidence in DRF, and we wrote a paper that called out to the compiler and PL community saying, hey, you guys have to get into this problem, and this is not an architecture thing anymore. You need to jump in. And this got the attention of Bill Pugh. He was thinking about the Java memory model. He wrote to me saying, "Do you want to join the effort?" I said, "Yeah." And then we worked on the Java memory model for 5 years. That community was adoption of DRF was very easy for that community. But for the Java memory model, there were other aspects because programs with data races also needed semantics because of security reasons. And this turned out to be a really, really hard problem. Took a long time, and really this final solution was not great. It still has holes. We knew it then, but it was the best we can do. And huge impact, right? This was the first real specification of well, the original Java programming language also had a specification, but that was pretty badly broken. So anyway, so I like to joke with Vikram, who's a PL person, that I'm a co-author of a chapter on the Java language specification book. But anyway, the next Hans Bohm, who was also active in the Java memory model, he reached out to me about the C++ model, and that there's a whole story here. And finally, there was convergence, but still many open problems. And then I wrote another paper with Hans about making a case for rethinking parallel languages in hardware, because this whole memory model problem was just, there was fundamentally an issue here. There were some fundamental issues that were broken, and my feeling was that all that we were trying to do was put Band-Aid on those broken things. And again, this whole understanding and passion happened because of thinking about the whole problem and working for so many years on it. So one of the broken things was something called relaxed atomics. I don't want to go into it in detail here, but with John here and Matt Sinclair, another PhD student, we started to attack that problem. And I love this quote here. Just to show where you get motivation from, talking to people and keeping your passion alive. And so some employee from a major research lab wrote to us that C++ relaxed atomics were the worst idea ever. I just spent days and days trying to get something to work. My example only has 2 addresses and 4 accesses. It shouldn't be this hard. Can you help? Right? And you see something like this, and you get something like this only because you're talking to people all the time, right? This was Matt talking to this person, and you see something like this, and it keeps you going for another few years, right? It keeps that passion up. It reminds you why you're solving the problem. It tells you, what kind of impact this problem needs to have and who it needs to address, right? And so we came up with a solution. It was published in Discuss 17. This is still unfolding. And we will see where it goes. And then, while all this was happening, I started to realize that that this memory model stuff being so broken also has an impact on cache coherence, and sort of loop back again to fundamentals for cache coherence, asking questions like, what does cache coherence actually mean? Who needs it? When? And so started off on a software-centric view of coherence tangent that I briefly described, exploiting some language level constraints, etc., and truly identified, what is fundamental, what are the minimal mechanisms we need, and at least in my mind, I was just like, it was a huge deal, just understanding all of that. But the de novo protocol did not get anywhere because at that time, okay, a lot has happened since then. At that time, it did not get anywhere because first it had these constraints, and second, the companies were entrenched. Their cache coherence mechanisms, one of the most complicated things in the system, and nobody wants to change it. But then slowly we relaxed the constraints, and now de novo doesn't need any of those constraints. Or the versions of de novo we used, and then the big thing that happened was architecture enters the golden age with heterogeneous computing, etc. All of the constraints have changed now. It's a whole different world, and it was sort of a deja vu moment for coherence and consistency. And the next phase with John and Matt and Juan and other students, we developed the spandex coherence interface for heterogeneous coherence, and this is still unfolding, but lots of things happening. We're going to tape out a chip with a big DARPA project, and very excited about this project. But it all came from that initial sort of idea and understanding of what is required for coherence for well-written programs. Okay. And now Elixir is is this current passion. Again, it follows from the story that I just described. And how does it follow? Well, golden age and all is just fine, right? We're doing domain-specific systems, domain-specific architectures, but that also means that our work has to be grounded in these domains, right? You can't build ideas for domain-specific systems without checking them out for different domains. And machine learning is all great, right? There's been a plethora of machine learning accelerators, awesome, but that's not the be-all and end-all. So, and also looking at just one machine learning accelerator was just not exciting to me. I wanted to think about the entire system, end to end. Okay, what do we really need to build the entire system and have it obey end-to-end quality of service, quality of experience requirements with the appropriate power, performance, etc. And so we hit upon extended reality, and I have a whole talk telling you why this is just an amazing domain, because it covers graphics, it covers audio, vision, robotics, all sorts of subdomains. There's orders of magnitude difference between the performance and quality that you see in today's systems and what we really need. So it's a huge playground for people like me who like to think cross-layer, end-to-end, big picture kind of full system things. And so that was all very good. But when we started the work, we realized, hey, nobody, most of the XR stuff is proprietary. It's mostly companies working on this. How do you even start to make a difference here? And so we started to work on an open source test bed so that people could actually, literally to democratize extended reality research development and benchmarking. And this became a huge effort for us. There's lots of industry interest, lots of exciting research that we are doing. And again, this is not as yet published. Hopefully soon. But a big part of what I'm doing. So passion is easy, right? If you think hard about your problem, really understand it, really know why you're doing what you're doing, it's easy to be passionate. Okay, so that was my story about the third habit. And then the final thing, which may be the most important at all, right? It's for me, like for me personally, again, this is a personal thing. People are really, really important. People make me fly. Okay. And so for me, it's really important to build relationships and surround myself with happy people, optimistic people, positive people, people who make me feel good about myself and make me feel like I can do anything I want to do. And then to pay it forward, right? So this is a community. It's really, really important for me, and I hope you will take this lesson from here. If nothing else, take this lesson. Pay it forward. Right? Be kind, be helpful, encourage. You might think you're junior right now, but there's someone even more junior than you that you can encourage and be a mentor to. Okay, so for me, it's all about people, really, about people. As you've seen, all of the work I've done has been with lots of collaborators, lots of people that have been involved with faculty, industry, colleagues, students, etc. I've been super fortunate to have some amazing mentors. Mark Hill, my advisor, and Janie Urban has been just an amazing source of inspiration and encouragement. Joel sitting here, Joel may not know this, but he's inspired me a lot. I think he knows this though. And my family, we're very close, not just the four of us, but also my extended family. And pay it forward. I hope I can do for others what all of these amazing people have done for me. So I'll stop here.
Thanks, Sarita. It was a great talk, a lot of great advice. Once again, if there,
yeah.
Oh wow, we got a lot of.
Yeah. And then I want to put that code back again. So remember, you're all going to be successful. Okay, the only question is what shape is that success going to take? Yeah. Okay.
Awesome. So yeah, once again, the chat here is disabled on the Zoom. So if the audience has any questions, you can enter those in Clouder or just raise your hand, and we can call on you. If there aren't any immediately, I got a few questions while people think on that. So Sarita, maybe out of necessity, you could be considered kind of an expert on advocating for yourself. Do you have any advice for people who, are maybe less comfortable advocating for themselves, their ideas, the importance of anything?
Yeah. I think John may be surprised to hear that I was actually a big introvert. Again, it's something, and even now, posting on social media, etc. I just don't feel like doing it. I sent my first LinkedIn message 2-3 days ago, advertising some work, and I don't think I've myself tweeted about my work or so on. So if you're uncomfortable, advocating for yourself, please know that that's normal and natural. Okay, that's not, again, it's a habit, right? It's a habit that you create, and you want to be judicious about how you advocate for yourself. For me, the passion comes first. I think if you believe in what you do, it's easy to advocate for it, right? I don't have a. I think the annoying things are when you're doing stuff that, like, if a person's always tweeting about every single paper that they published, I'm like, give me a break, right? I mean, it's like, I don't believe you. But if you truly believe in what you do, and you advocate for it, I think it comes across as sincere, right? And that you're trying to really just convey something you're excited about, and you're trying to um, uh, um, change people's minds. I don't know what else to say. um, it, yeah. I don't know, John, if that's what you were looking for. That wasn't a very good answer.
That's good.
Yeah, I guess the thing is, if you care about your work, the advocacy will come. Okay, so care about what you're doing, and then you will feel more and more comfortable. And then, okay, let me give a slightly better answer. Let me just go back again. This thing about creating habits. So I still remember my very first paper, ISCA 1990. There was an excursion from the conference site. So in Seattle, from the conference site to some island somewhere. It was a long boat ride, like, I don't know, in hours. Okay, that whole thing I spent arguing about my approach with Alan Gottlieb. Okay, literally that whole ride, and I was just like a young grad student. But I don't. You could call that advocating, but I would call that discussing, like, telling people what you're doing, changing their minds, and etc., etc. So if you do that kind of, if you advocate in that kind of way, I think it's fine. It works out really well. There's another kind of advocacy, which I don't know, John, if you were asking me about that. So the other kind of advocacy is where uh, you are being taken advantage of, or um, there's just, it's somebody is misbehaving, and we've seen some of that in recent years in our community, unfortunately. There, um, definitely make sure that you are getting what you deserve. Make sure to speak up for yourself, and this is where the build relationships thing comes in. All these failures here. I told you about how when I was this time I went to my advisor and cried. Actually, I cried here at this point with him here, and I think after this point I stopped crying to him. But but my point is that find the people who will advocate for you. Find the people who will help you advocate for yourself. Um, just if somebody's Find the people who make you feel good about yourself, and just build those relationships, sustain them, which takes a lot of effort, by the way. It's not easy to do that. Okay.
Good, thanks.
That's all I have to say.
And okay, it looks like we have at least one question. Christian?
Yes, this is Christian. This is a great presentation, Sarita. I really like your story. I really like your story behind the story, and I think you also partially answered my question already. That is, I think you had mentioned a few times that you were about to quit, or about to, or let's say in a bad situation. What were your turning points? Why you decided to continue? I mean, I assume it couldn't be only passion, because you cannot make with passion, and you already mentioned the relationships, the people, maybe also the success that you did in the meantime.
So I don't know, we can pick whichever. So to me, I think the closest that I came to quitting was after my child was first, during that first couple of years of my first child. I think that was probably the hardest period of my life. And it just so happened that Barbara Liskov visited us here. And the particular thing that I was going through, so this is kind of personal, but you know, it's all, there's really no difference between personal and professional when it comes to some of these things. So my child, daycare wasn't working for him. We had some family problems. So the arrangements that I'd made for childcare had completely fallen apart. You know, the arrangements that my husband had made, it completely fallen apart. And it was just, it was just crazy. So Barbara Liskov happened to visit, and I happened to tell her that this was going on, and so and so and so and so on. And she just made a comment. She said, you know, why don't you get a nanny? And you know, I grew up in India, and just the thought of leaving my child with some stranger, you know, all day long was just completely not something that I had ever entertained. And she just talked to me about it, and she told me a few things. I'm happy to elaborate. We're running out of time. I'm happy to talk about this in more detail, but she just explained it in a way. She told me a few things that just, I mean, that made a lot of sense. We hired a nanny, and it may seem to you all like you know, just a one thing here, but it literally changed our lives. Just changed, you know, how much time we had and so on. It didn't make things that much, you know, it's not like as if the difficulties went away, but it's just having one additional person to help us, support us, just made all the difference. And so that's one example. And over you find that you know, I talked about people, and with Barbara I didn't have a relationship, but it's just, you know, talking to people when you're in trouble. Another thing is, don't be afraid to ask for help. You know, that's one thing that often students don't do. They don't reach out, and they don't tell either your advisor or friends or whatever, you know, I'm struggling. The one thing you should take from here is everybody struggles, right? I just won't believe it if someone says they didn't struggle, right? It's just not a thing. So everybody struggles. Ask for help, talk about your problems openly, and the solutions will emerge. And then I can tell you other places also, right? I mean, there's obviously stories, yeah. But I'm mindful of the time, so.
Thank you so much.
Yeah, I think we have time for maybe one more quick question, if anybody else has one. Mengja, it looks like you have one.
Yes, I think really, really great talk, because when Sarita was talking, I just feel like all she said is just, when I hear she said all these things, I'm reflecting on my PhD, and everything is exactly what as she said. Everyone is struggling. I've been talking to so many lab mates and peers. They all struggle about PhD. No one didn't struggle, okay? And especially if something becomes successful, you kind of start forgetting things. It's like, for example, me, after I got my job offer, I kind of think that everything happening in my PhD it's not that sad. So it's so easy to forget. So I really appreciate that you can tell all the things happened behind all the successful image of you, and sharing all this with us. It's really encouraging to all the junior students. I just have one question. That I also believe passion is very important. Otherwise, you cannot just strive through the tough 5-6 years in your PhD life. I just want to ask, what can I do as an advisor to encourage my student to become passionate about things I'm passionate about?
Yeah. That's a whole different talk. Yeah. Yeah, how many minutes do I have to answer this question?
Maybe we can keep it to the other post session, or the roundtable mentoring session if you are available at that time. It's more like an answer for me, but I just really want to see that how advisor can help students to develop this passion, because when they are junior, they didn't really see the whole field. So I feel like it's really difficult to have the passion. As you mentioned, you have to understand things before, so that you can have the passion. But it's so difficult for them to understand initially, especially in the first 2 years of the PhD, right?
Yeah, and I'll say, as an advisor, the advice that the tenet that I go by is that the student has to be passionate from their inside, right? And so if the student, you know, each student has their own skill set, right? They have their own worldview and certain things that excite them. And so as an advisor, it's our job to adapt to the student. And so for me, I work on a broad set of things, and I feel that pretty much for every student, I think I can adapt my own desires for what I want to accomplish to what the student, the student's worldview and the student's skill set will enable them to be passionate about and enable them to accomplish. So you need to sort of create this, a frictionless kind of kind of a system where both of you are passionate about the same thing, and it might require both of you to bend a little, turn a little, right? Adapt to each other. Again, there's so much people stuff, right? We talk about ourselves as a very objective, quantitative field, but really a lot of what goes along is about getting the best out of people.
Yeah, exactly. Thank you so much.
Thank you, Sarita.